So here we are given a problem based on joint probability density function. So we are having a bivariate random variable xy and their joint probability distribution is given as 8xy, and the limit of x and y is dependent, that is 0 less than y less than x less than 1, and we have to check whether x and y are independent, and we have to find the probability of x plus y less than 1. So first question, to check whether x and y are independent, we have to check whether the product of their marginal densities, that is product of marginal density of x and marginal density of y, if that is equal to f of xy, then we can say that it is independent. So for checking independence, we have to first find the marginal density functions of x and y. So we can see what is the marginal density function of x. So marginal density function of x, we can denote that by f1x. So f1x, this can be find out by integrating our function, joint probability density function, with respect to y. Okay, so for finding marginal density function of x, we have to integrate the joint probability density function with respect to y. So which is equal to integral, and the limit of y is ranging from 0 to x. So integral 0 to x, f of xy is 8xy, 8xy dy. So since this integral is with respect to y, 8x is the constant term, so we can take that outside the integral. Then 0 to x y dy, which is equal to 8x. So integral y is y square by 2 over the limit 0 to x. So we can cancel this 2 and 8. So 4x, and now we can apply the limit. So apply the limit. So x square minus 0 square, that is 4x cube, and x is actually lying between 0 and 1. So we can write the limit of x as 0 less than x less than 1. So this is the marginal distribution of x. So in a similar way, we can find the marginal distribution of y. So marginal distribution of y. So marginal distribution of y is denoted as f2y, which is equal to, we have to integrate the f of x with respect to x. So if you want to find the marginal distribution of y, you have to integrate f of xy with respect to x. Okay, so integral. So what is the limit of y? So limit of x is from y to 1. Okay, so limit of x is from y to 1. So we can substitute that. So integral y to 1 f of xy is 8xy, 8xy dx. Now since this is the integral with respect to x, we can take 8y as constant term outside the integral. Integral y to 1 8x dx. So which is equal to 8y, sorry, we have taken 8 outside. Okay, integral x dx. So integral x dx is x square by 2 over the limit y to 1. Now we can cancel this. So 4y, and applying the limit 1 square minus y square. So this is f2y, and limit of y is 0 to 1 again. So 0 less than y less than 1. Now we can check whether x and y are independent. So for checking this, I am multiplying f1x and f2y. So f1x is 4x cube into f2y 4y into 1 minus y square, which is equal to 16x cube y into 1 minus y square, which is definitely not equal to 8xy, okay, which is our f of xy. So since f1x into f2y not equal to f of xy, we can say that x and y are not independent. Now in the second question we have to find the probability that x plus y less than 1. So let us see the area of this density and this area. Okay. So we are having x plus y less than 1. So equation of the straight line will be x plus y equal to 1. So for drawing the line, we can take the value of x and y. If x is equal to 0, what will happen? If x equal to 0, y will be 1. If y equal to 0 in this equation, x will be 1. Okay, so this will be when y is equal to 0, x equal to 1, and when x equal to 0, y equal to 1. This will be the point. We can join this point. Now consider our limit. So 0 less than y. So we can consider what? Y equal to 0. So y equal to 0 is the line of what? This will be y equal to 0 point. This will be the line, that is, this will be the line of y equal to 0. Okay, then that is whatever be the value of x, if x equal to 0.5, y will be 0. If x equal to 1, y will be 0. So this is the line. And y less than x, consider that. That means x equal to y. So what will be the line? Whatever be the value of x, that will be equal to y. That means if x is equal to 0.5, y is also 0.5. And if x equal to 1, y is equal to 1. So this will be a diagonal line. Okay, this will be the diagonal line. Now we are having x less than 1. So that will be x equal to 1 line will be this, and less than 1. So we can consider the common shaded portion, that is, we have to find probability of x plus y less than 1. So what will be the common shaded portion? X less than 1, the shading will be there here, and x plus y less than 1. So this is the line of x plus y less than 1, shading will be here. Then x less than y, so this will be the region. So considering all this, and x and y lies between 0 and 1. Okay, so considering this, this will be our region. So we have to find the area of this region. So here the value of x will be ranging from, okay, so consider y. Here y is equal to 1 by 2, right? Y is equal to 1 by 2. So y is ranging from 0 to 1 by 2, and our region is x plus y less than 1. So range of x will be what? Y to 1 minus y. Okay, lower limit of x is 0, sorry, y, and x plus y less than 1 means what will happen? X will be 1 minus y. So we are going to integrate y from 0 to 1 by 2, and x is from y to 1 minus y. Okay, so probability of x plus y less than 1 which will be equal to integral y is ranging from 0 to 1 by 2 and x is ranging from y to 1 minus y f of xy dx dy. So which is equal to integral y is equal to 0 to 1 by 2 integral y is equal to 1 minus y f of xy is 8xy dx dy. Now we are going to integrate with respect to x first. So we can take 8y dy outside. So integral y is equal to 0 to 1 by 2. 8 can be taken outside the integral and y integral y to 1 minus y x dx dy. So which is equal to 8 integral y equal to 0 to 1 by 2 y into this is x square by 2 over the limit y to 1 minus y dy. So apply the limit y is equal to 0 to 1 by 2. We can take this 2 outside. Okay. Y. Now apply the limit 1 minus y whole square minus y square dy. So after integrating we will be getting like this, and applying the limit and on simplification we will get the answer as 1 by 6.